All right, good afternoon, ladies and gentlemen. Welcome to topic 11, where we're going to be converting different units of measurement. This section's really, or topic's really broken into two big pieces. That's customary units and metric units, and they both behave very differently. Here we'll be talking about converting customary units of time, weight, length, and capacity. So some notes, things to fill in as we go along. So customary units refers to measurements that are primarily used in the United States. There is only one other country in the world that I believe uses the customary measurement system. It's in Asia. If you find out what it is, come and tell me, and there will be a prize. Okay. Customary units of measurement refer to capacity, length, weight, and then also time. Capacity is the amount of space inside an object. It's how much it can hold. Capacity is a really formal way of talking about volume, which we just talked about in topic 10. Length refers to the distance from one end to the other, or how long something is. Weight is how heavy an object is. These should be words you're familiar with. These last two might be new, and they are possibly the most important ones on the page. A ratio is a comparison, I might have spelled that right, of two units or objects. For example, days to weeks, right? There are 7 days to 1 week. There are 14 days in 2 weeks, right? Or feet to inches. 1 foot is 12 inches. Right? In addition to being able to being written like that, you can also write, I'm going to erase this one, you can also write a ratio as a fraction. So 1 foot, right, is 12 inches. A proportion is a pair of equivalent ratios, right, can be used to find missing measurements. That says measurements. Okay. All right. What I want you to do right now is pause this screen and fill in any of these abbreviations that you know how to. Test yourself, see how many you can do without just copying them straight off the screen. It's important to pay attention to these abbreviations because they represent different units of measurement, and when you're converting from one unit to another, you need to know where you're starting and where you're going. The only ones that I'm going to point out are ones that are a little bit weird. For example, you'll notice there are two things that say ounces. One measures fluids, liquids. One measures weight, or how heavy things are. Secondly, there are several ways to represent pounds. This is actually called the pound sign, so you might see that. And then finally, when you're talking about height or length, sometimes for feet they use an apostrophe or a single tick mark, and for inches they use quotations. You may or may not have seen that on like the back of a sports card or trading card to refer to the height of an athlete. All right. So you can make conversions within the different units of measure by using ratios, right? Which is what we're going to talk about for the rest of this video. So using the original unit ratio to make our equivalent ratio for different sizes. So here are some unit ratios you will need. Again, pause the screen, see if you can fill any of these in. Okay. So hopefully you knew some of those from the past, but if not, get them all filled in. This particular page of your notes, as well as a cheat sheet that I'm going to give you with all of these on it, can be used on any assignment, homework, IXL, test, anything you want. All right, so for the rest of the video, you can put your pencil down and just listen. I just want to talk about how ratios work. This is not in the notes, just watch. So from earlier, right, a ratio is a comparison of two quantities, two amounts. So it's boys to girls or adults to students, feet to inches. Ratios can be written in several ways. So if we talk about, we're going to talk about the green team teachers. Okay, there are 5 of us. There are 3 boys to 2 girls. You can write it like that, right? So it would be 3 to 2. You can also write it as a fraction, right? So 3 boys, 2 girls. Right? You could have also flipped it. Okay? Equivalent ratios work just like equivalent fractions, though. So let's say that on the green team, I have 3 male teachers, 3 boys, for every 2 girls. Okay? So this is one team. Right? What if I told you that in the building there were a total of 12 boys? And I asked you how many female teachers there were. Okay? So you would ask yourself, right, how did I get from 3 to 4? Excuse me, 3 to 12. Gave you the answer on that one. Right? I multiplied it by 4. Okay? So I would have to do the same thing to my denominator. So 4 times 2. If there are 12 male teachers, according to this ratio, there are 8 females. Okay? What if I told you that for every, right, let's see here, for every 1 candy bar, maybe, right, so for every 1 candy bar, 1 piece of candy, I have to eat 5 vegetables. And I just got, you know, a whole bag of Reese's, and inside there were 20 Reese cups, and I wanted to eat all of them. How many vegetables would I need to eat? Okay. How did I get from 1 to 20? Times 20. So down here, I also need to multiply by 20. So 20 times 5 would give me 100 vegetables. Right? Ratios work just like equivalent fractions. So your next steps would be to practice converting measurement using ratios for length, weight, capacity, and time, which are the next sections of the menu. This is just your introduction. So come and see me with questions, but have a good day.